In the last example I gave of solving quadratics, we used observation. We could just say, oh, well, what would x have to be in order for this first bit to be 0? Well, a -4 would be the answer. We just, because -4 and a 4 is 0. Or we could say, what would x have to be here in order for the second part to be 0? Well, 6 minus 6 is 0, so the solution would be 6. But sometimes they're less easy to see, and it's also quite good to have another approach. So we know that either this or that must be 0 in order for the whole thing to be 0. So I can actually write that out. I could say either x plus 4, and I'm going to take them out of their brackets. I don't need the brackets because I'm treating them now individually, is 0. Or we could say x minus 6 equals 0. Now, if x plus 4 equals 0, I'll rewrite this. I go x plus 4, and I'm going to, this time, going to subtract 4 from both sides. And of course, 4 minus 4 leaves me with an x, and x is -4. So there is my first solution. But if x minus 6 was 0, well, I'll write it again. X minus 6 is 0. I'm going to add 6 to both sides. There it is. Because a 6 and a -6 leaves me with x is 0. So I've got a 0 and a 6 is going to be 6. So my solutions are going to be either x equals -4 or x equals 6. You could leave it like that, or you could say x is an element of, and again, I'm going to write it in set builder notation in ascending order, that is smallest or the lowest number to the biggest number, -4, 6. And there is my solution.